remind you that we shouldn't think that a lowering pH is always something getting taken away, right? If we have a buffer system in our body, in our renal component, and we have a respiratory component, we're either adding acid to throw that off or adding base or subtracting one or the other. But it doesn't necessarily mean that if I remove acid, it could also be adding it, is the only reason I put this here. Okay, you ready for some big math?
Mm-hmm.
Big mathing out here. H stands for hydrogen ions, and it is our pH. CO2 is carbon dioxide, or often referred to as PaCO2 regarding the pressure. And HCO3, which is our bicarbonate and governing our metabolic component. Hang on a second. There are other components that we need to discuss, and that's water and carbonic acid. Because what we're talking about when we say, like, CO2 is not an acid, okay? But CO2 plus water makes carbonic acid. So therefore, more CO2 leads to more acid. What acid? Oh, did I make a mistake? Oh, I was gonna say, this is not like me.
You don't make mistakes. No, never.
Right, and if I do, it's someone else's fault.
Yeah.
Okay. What do we know? Ray, where does H? Wait, can we do that? No, that's not that can do. What about CO2? Where does CO2 fall on this equation? Yeah, well done. Okay. Tina, what about HCO3?
CO3 is a carbonic acid.
HCO3 is bicarb.
Oh, I was thinking H2, sorry.
Okay.
That's metabolic.
It's metabolic, right? Now you'll notice I've already put carbonic acid in the center. This is the center of the universe. Built to Spill has a song called Center of the Universe. It's amazing. Now, to get carbonic acid, we can combine CO2 and H2O. That'll make carbonic acid. But so too, if we have HCO3 or bicarb and hydrogen ions. What happens if I add a whole bunch of hydrogen ions to a body? It becomes more acidic. Very good. And so to balance that out and to have a stable formula to create carbonic acid, essentially, I need to combine HCO3 and hydrogen. So what this means is when one of these... When these things tip in one way or the other, they have to increase where the other decreases to balance it out. Meaning, if my ventilatory rate falls, so my CO2 rises, to balance it out, I would have to make my HCO3 rise. I think we have time for this big one. So let's recap this, right? India, what's the normal pH level for blood?
3.5 to 4.5.
7.35, 7.45, right? And if you're less than 4, you're technically normal acidic, or less than 7.35, you're acidic, right? Peyton, what's the normal range for the PaCO2?
I have no.
Now, the normal range for the PaCO2 is the same one as the pH, 35 to 45. The problem is more acid makes you acidic, right? So if I am at 0 and I add acid, my PaCO2 goes to 1. If I add more acid, it goes to 2, 3, 4, 5. So if the normal range is 35 and 45, it actually has to be reversed here because more acid leads to a higher number in regards to the PaCO2. So if I said that your patient has a PaCO2 of 46, would they be acidic or alkalotic? Acidic. Now HCO3 is its own number. Courtney, you remember HCO3? No is a fine answer.
Yeah, no.
Idiot!
I tried.
No, I'm just kidding. I'm just kidding. This takes a while. Oh, we got it over there? Wow, it's contagious. Okay, so as you can see here, be careful. A low pH is acidic, a low HCO3 implies acidity, and a high PaCO2 is acidic. Be careful there. All right. So reviewing these three main questions, what we're talking about is my patient acidic or alkalotic? And that's governed by pH, right? My pH is low, I'm acidic. My pH is high, I'm alkalotic. But the next question is respiratory or metabolic. How do I determine whether or not it's the respiratory's fault or the metabolic fault? Well, it depends. Which one is out of whack? Is your CO2 out of whack, implying respiratory? Or is your H3 out of whack, implying metabolic? The third question we'll get into is compensation. If your pH is perfect, but one of these components is out of whack, then you're balancing it. You're compensating. That's probably the hardest concept to get. We'll save that for the end. Please.
Is there a scenario where, like, I'm thinking in my head, like, we pull up to a nursing home where they already have all this information, and you're like, thank God.
Yeah, and probably less a nursing home simply because they have to send it out to a lab.
So,
But
it's
yeah,
not
like if you go to a
something-
doctor's office and he says, hey, here's the labs, absolutely you could have these numbers. What's funny about all of this knowledge and somewhat frustrating is I'm like, their pH is this, their SpO2 is that, their HCO3 is da-da-da-da, all these different things, and you're like, whoa. But like he's breathing at 8, so I just ventilate, right? Like that's what I'm doing. And you're like, yeah, well wait though, because like, blah, blah, blah.
I'm not gonna do that, but thanks though.
Yeah. All I mean to say is like, be careful here. Like this stuff is good to know because it helps you build a foundation of understanding physiology, pathophysiology. But mostly, I'm like, I already taught you all the stuff you need to know, really, as far as saving lives, right? Throw them on end tidal, right? If their EtCO2 goes too far out of whack, slow it down, speed it up, blammo. All right. I want you to take a second here and just draw this. There are two ways that I know how to teach end tidal or not end tidal, but ABG, and you can either do it this way or what's called the Rome method, R-O-M-E. I don't like it, I don't use it, I don't teach it. But if you get through this tic-tac-toe thing, dude, this made no sense. R-O-M-E is what you'll want to Google. It's something about the difference between pictures and math brains or something. So R-O-M-E is what you're looking for if this doesn't work out. So what I'm drawing here is I'm drawing my acid. I'm got it like this. It's like this, like that, and then I have my normal. And then I have alkalosis. Aclosis. Let's do it. Aclosis.
Makes sense.
Okay. What goes over here and is not listed is pH. Okay, that's what goes in this row. This is my pH. And what goes in this row here, we'll just call comp or component or whatever, because this is where my HCO3 and my CO2 are going. So I just know this as pH goes in the first row, the component goes in the second row. If I had a patient whose pH was 7.25, where would it go? Right here, okay? What's important to note is that this point right here is 7.35, and this point is 7.45, which means there is a perfect normal 7.4 here. Okay? Okay. So if I said your patient's pH is 7.41, I should call that normal. It's in a normal range, but it's not perfect, meaning something is changing, something's happening. Okay? Here's what we're talking about. If it's above 7.45, we would call that alkalosis. However, it can still be alkalotic without being alkalosis. It could still be too high without being pathologically high. Here's a good example of that. We have VQ mismatch as a normal process, don't we? But VQ mismatch is bad, right? Well, it's kind of how the language changes. Extreme VQ mismatch. Is it bad to have a pH of 7.41? Not really. Oh, so alkalosis isn't a problem? Well, it's not alkalosis, it's an alkalotic situation, but he's yet to be in a state of alkalosis. He's compensating. Anyway, the point is if you just remember that it's a normal range between 735 and 745, you're gonna be okay. But the only way you can really verify that this system isn't working in some way or another is if he's at 7.4 dead nuts in the middle. Everyone shut up, my wife messaged me. Did you just buy something?
Oh, yeah, I ordered that same.
Just be like, that's supposed to be a surprise, and then go buy something.
Huh?
Just be like, that's supposed to be a surprise. Oh, gee, and then go buy something.
Yeah.
What you got?
We got this? pH goes on one side or the other? Okay. Now, to be somewhat conscientious of this, right, of the movement of this, if my pH is moving from 741 to 745, this means that there is something happening. The only way I want you to say that my patient isn't suffering a pathological situation in any way is if his pH is at 7.4. Because if it's 7.41, that means that his body is balancing something now. If it's 7.39, his body is balancing something now. We know he's in compensation now. Now when we talk about CO2, again, remember that it's somewhat reversed here. If it's above 45, we would put it in the acidosis category. If it was below 35, we would put it in the alkalosis category. And when we kind of go through some of these practice things, that's what we're going to say. I'm going to say to you, hey, your patient has a CO2 of 46. Well, then you'd come over here and you'd say, well, CO2 belongs here in the acidic state. I say, well, your patient's CO2 is 10. Oh, well, that's not here. 10 goes here for CO2. And that's how we'll be working this out. HCO3 goes in the same row, but remember the number movement is reversed, meaning if I said to you, hey, your patient, Amanda, if I said your patient has a CO2 of 50 and an HCO3 of 5, where would those go?
CO2 of 50?
Yep. Is Coca-Cola an acid?
Yes.
Is there CO2 in it? So more Coca-Cola makes you,
More acidic.
Right.
So it go.
it would go, we would put CO2 here in the acidic
Yes.
category because it's 50.
Mhm.
Okay, well where would I put HCO3 if it was 5?
There's 5.
Mm-hmm.
Alkalosis.
What's the normal range, right? Below 21?
Oh, sorry.
Well, I ask you this on purpose because that's what happens. You're like, high numbers mean acid. Wait, not for bicarb. So low numbers mean acid. Wait, not for CO2. Right.
I see it backwards.
Did you hear just the number 5, not 25?
I did say 5. It's,
Yeah. My brain just went the number 5, not 25.
That would still work. Either way, the point I'm making, so let me give you all a test thing, and you might end up kind of drawing this several times here to kind of play along, but let me give you a set of numbers here, right? What I want you to do is patient has a pH of 7.1. So put that in the appropriate corresponding category. Your patient has a pH of 7.1. Your patient's PaCO2 is 56. Your patient's CO2 is 56. You already got this, Tony? What are you doing not writing? Your HCO3 is 30. Tony, come up here and fill it in for me. Do you remember the pH?
30.
7.2 is the pH.
Okay.
How does it 7.1?
Oh, okay, 7.2. Sorry, 7.1. Not largely relevant, but 7.1.
Okay.
Okay, write it down. Where does it go?
It would go right
Very good, write it down. 7.1, fantastic. What did I say about the CO2?
56.
56, where did 56 go?
here. It would go right here.
No. Because if 56 is an increase of my CO2, that makes us acidic. Okay, so where would it go on that chart?
Then it would go right here.
Because it's an acid, so write 56 there. 20,
It was 30.
30. Okay, so if your patient's HCO3 is 30, where would that go?
That would go right.
Very good, so write it down. So now we can draw a distinction. Very good, Nancy. We can draw a distinction here. We see a correlation between the pH and the CO2. They are in the same column. So this means, is this patient acidic or alkalotic? Acidic, they are in respiratory acidosis. Now if I just change the pH, let's say that's the same composition here, I change the pH to 8, where does that go? Alkalosis, there's a correlation here. I am now in, this is my HCO3, is that respiratory or is that metabolic? So they are in metabolic alkalosis. I know their pH is wrong. I know their pH is pathological because it's not dead center. The question is, which of those other components are in the same column, are doing the work? Since this, now this is a natural process for these things to be opposite. Why is that?
Is it going to be one or the other?
It will be one or the other. In fact, it would be worse if this was normal. Trinity, why is it that it's actually a good thing that if this one's all the way over here, this one's all the way over there,
Your body's trying to compensate with what it can't control.
right? If my bicarb is forcing my pH down, I want my acid to force the other way to help balance out my pH. So in fact, the fact that this is even over here is signaling that my body is attempting to compensate for it. All right, let's try another one. I know it can be embarrassing to be up here, but I can assure you, one of the easiest ways to get this is by physically doing it. So, who wants to do another one? India? I saw your body move.
Because I looked up.
Don't look at me. No. I love what you do me. All right. Let's say that your patient has a pH of 7.7. Okay. And let's say that they have a PaCO2 of 30.
30.
Mm-hmm.
Like,
It would not. So where the PaCO2 goes, right? So if I have, this is my pH, 735, 745. What I have here is, for my PaCO2, I have 45 here, and I have 35 here. Yeah? Okay, so we got the dot there, very good. Okay, now I have a HCO3 that is 10. Okay, so Dot, what is your patient's condition?
Alcoholic.
Alcoholic what?
Metabolic? Oh, yeah.
Sure. The options are respiratory or metabolic.
Okay.
Which of these fall in the same column as the pH? So if our CO2, very good, thank you. If yours, you can, I believe in you. If your CO2 is alkalotic and your pH, let's just say 7.5, indicates that, well, there's a correlation here, so now I think metabolic alkalosis. Right?
Respiratory.
Respiratory acidosis.
wait,
I was just wait, yeah, I was like, wait a minute, wait.
Respiratory because CO2 is governed by the lungs, right? They're like, wait, suddenly?
Yeah,
I don't know.
I don't know. I don't know.
So as you can see,
Nothing.
and we could go through this time and time again, but the results will come up pretty obvious. What it is basically is like, which one of these falls on the side of crazy, and which of the pHs lines up with it, right? Pretty much over and over, right?
I like this.
Because in most situations, your body is going to be trying to compensate, yeah? But we come into some problems, or it becomes a little more complicated when we ask ourselves, what if the body is or isn't compensating?
I'm confused about, so you're lining it up, or you're looking at, are they in metabolic alkalosis or acidosis?
Yep.
Respiratory alkalosis or acidosis?
Correct.
But you're seeing under which category it's falling with the pH because,
Okay, come up here. The like sachet up here.
Pause for a second.
That's why I underlined it. You weren't with me on my journey as I continuously just, I gave up and just made up letters at some point. Aclaoncinus, I don't know. Okay. Boom.
Yeah, I didn't do that.
Do you see the scale here of 735 to 745?
that's the pH.
Okay,
Yeah.
where would I put a lemon?
I'll have to look at the chart, but I'm assuming it's acidic.
Yeah, me too, right? So right there.
Yeah.
Okay. Where would I put milk, which is a base?
Base would be under alkalosis.
Boom. So that's how I know whether or not if I were to test the,
Right, I get that part, but going back to the, like if you said, okay, this patient's
sure, let's play.
CO2 is 32, so
Hang
that
on,
would
let's
be
back up. Give me a pH.
7.6.
7.6, okay, right here, 7.6, cool. Give me a CO2.
Okay, it's 32.
Okay, 32 would fall over here, okay? Now, I won't ask you for the next one. Let's just assume that HCO3 falls over here. We'll get into it later. So, boom, acidosis. This is my CO2, which is respiratory, right? So I know now that this is respiratory acidosis.
Alkalosis.
Oh.
It's okay, guys. We got this.
Too many
You need to
A's.
stop talking so fast.
I mean,
Let
these
your
two
brain
are
and
generally
words
going
catch
to
up.
fall into different categories anyways, because one's compensating for the
Generally.
other.
Generally.
So whichever one lines up with that
That's
same
right.
category on the
It's so long as you
pH.
use the correct word, it'll be fine.
Okay.
Yeah. Right? And so the reverse is also true. If you said, oh, your pH is a 2.1, it's like, holy crap, this doesn't sound possible. And you say, okay, well, my HCO3 is 10. Okay, well, that also falls in acidosis. And it's very likely that in a normal situation, your body's going to be trying hard to compensate. We're just going to throw your CO2 over here into an alkalotic state, right? So this would be, I don't remember which, I guess this would be metabolic acidosis, right? And so we can kind of see it in this picture here, where I have, if the pH is under the same column as the CO2, which is respiratory, well, we know that to be respiratory in nature. In this case, it's represented as respiratory acidosis. And in this case, the pH is in the same column as the HCO3, which makes us understand that this is metabolic alkalosis. Almost again. But the reverse can also be true. Right, as you can see now, the pH is in the same category as the CO2, but now it's in an alkalotic state. So we would call this respiratory alkalosis. Right? And so whatever they fall into the column with, that's how we're going to describe them.
Are we just doing this for the purposes of understanding it? Because we won't know their pH, will we?
Nope.
That's good.
But you will have, I guarantee you, I guarantee you, you will have 2 to 5 questions on the registry
Okay.
that list these 3 numbers and you have to answer it.
Okay.
Yay.
Every time.
Just for funsies.
Yeah.
Just for funsies.
So the reverse here is also true, right? Amanda, my pH and my bicarb are falling in the same column. What is this patient's state?
Metabolic.
Whoa, good job. Yeah, that was fast too. Sick.
So brown.
Right. Here's the tricky part. And if I'm being honest, I don't think you're gonna get asked questions about compensation, but it's super cool and you're wicked smart, so here we go.
Okay.
The question comes into play, or a reasonable question might be asked, is if we're very used to, like, say, my HCO3 falling over here, and then my CO2 falling over here. But the question might become, wait a second, what happens when my bicarb doesn't fall over there, but rather falls in a normal range? I'm so used to it just being the opposite natural, right? Well, what that means is it's doing its job. It's balancing it out, right? My pH is alkalytic. Doing its job. My pH is, in this case, let's take this one specifically instead of, I guess, my example. I'm in an alkalytic state. Is that bad? Yes. I want to be in a normal state. So I am in an alkalotic state, right? If a person is breathing, let's just sidebar here. If a person is breathing 36 times a minute, an adult is breathing 36 times a minute, is something wrong? Yes, something is wrong. But we don't know whether it's the breathing or not. The breathing might be the cure, right? So if we know that a patient's pH is alkalotic, something is wrong. The question is, what is wrong? What is H3CO3? That's metabolic. So now we know what is wrong. They are in metabolic alkalosis. The fact that their CO2 is not over here means they are not compensating. They should be balancing the equation, but they're not. They're just up and up and up and up in the metabolic department. This patient here here's a question you got coming on a test, something like this. Your patient's pH is 8, your patient's HCO3 is 30, and his PaCO2 is 42. It's normal. What should you suspect about your patient's ventilatory status? Now, without the answers, it's hard because it depends on the timing of it. But what I'm saying is if we have a patient that isn't moving CO2, what should we suspect? That they're not breathing.
Yeah.
Or they're not breathing well enough, or whatever the case is. Whatever it is, their CO2 is falling in a normal range where we would actually want them to essentially be retaining CO2 to balance it out. Let's kind of move away from uncompensated. In a situation where a person's, this is somewhat misleading actually to me. Yeah, we can't really use that. That doesn't look accurate to me. Ignore the picture for now and let's just say this. If I have a patient where their pH falls within a normal range, okay? Now whether that's 736 or 744, it's in the normal range. It's not 7.4, so something is wrong, okay? And in this case, they say their HCO3 falls in an alkalosis or an alkalonousness, and their PaCO2 is over here, or their CO2 is over here. So you might look at it and say, look, let me just kind of cut to the quick here. I think we might have a much easier time with this. Oh, no, I really can't. Tell me this, you right now are in a normal state. You're not in acidosis, you're not in alkalosis. Not state of mind, okay? Where should pH, HCO3, and PaCO2 be on this chart for every one of us ideally? Right in the middle. And so really now, I'm also wondering if I shouldn't teach this all backwards, is that the normal state for everyone is that my CO2 is here and my HCO3 is here. And so what happens is one of these will start to shift. What would a patient be doing that their CO2 would start to shift higher and higher. What is happening with that patient? Hypoventilation, right? Okay, so they're hypoventilatory, very good everybody. Their CO2 is moving this way. What do we suspect about their pH now? It's gonna shift to the acidic side because they're retaining CO2, which combined with water is an acid and carbonic acid. So now their pH is starting to shift this way, and maybe it shifts all the way. Now in a healthy situation, where would the HCO3 wanna go? Because it needs to balance itself out, right? So we should expect this. Now, okay, so let's say our pH goes all the way over here. Now my HCO3 goes all the way over here. HCO3 is over here, and it balances it out perfectly. We should expect a pH right in the center if it's perfectly balanced. My patient essentially is fully compensating. How do I know that? Well, I know that they're in compensation first and foremost because it's not all falling perfectly. I know they're in some form of compensation because their HCO3 and their CO2 are out of whack. They're too far off the mark. But I know that he's not partially compensating. In fact, he's fully compensating because his pH is perfect. So what would it look like if good job CO2, or maybe bad job in this case, and good job HCO3 for balancing it out, how would I determine how could I determine who's at fault here? Let's say I told you, your patient's pH falls between 7.35 and 7.45. It is in a normal range. And so then you say, oh, so they're fine. No, they're not fine. Their CO2 falls way out of state in the acidic side, and their HCO3 falls way out of range on the alkalotic side. How could you know who's at fault? Trinity, what do you got?
It's like 7.39.
Let's say it was 7.39. Who's at fault? CO2. So your patient's state is,
Well,
right?
kind of.
They're not in acidosis, but they probably were.
Fully compensation.
They are at least in partial compensation. The only way we're going to get to full compensation
Is if that was
if it's perfect.
Partially compensated respiratory acidosis.
The only thing differentiating partially and fully is that pH?
Yeah.
Cool. Maybe you should teach us that.
But you're
You
never
make
gonna
much more sense
actually
for
know
yourself.
that because we're never gonna have these numbers.
You will know that on the test that determines whether or not you get a
Yeah.
license.
Welcome to the registry.
Right, but like out in the field, we're
Never.
never gonna know this. We have to have these numbers given to us in order to figure
You
things
will
out.
never be able to determine HCO3, that much is true, but you should have a suspicion of CO2 because you can check
the end title,
and title.
but you're not gonna have a pH,
No.
right? Like the only number that we'll ever really know is our end title CO2.
That is correct. Yeah, on a list of numbers like BP and heart rate, blah, blah, blah. But as far as blood gases, you won't know any of the blood gases. You can have a suspicion about one of them. Now, I could say, well then and I used to say, just sandbag those 2 or 3 questions. Let me focus on all the other stuff. But now I don't. What has happened for me is I have found, as an instructor, is that if I can teach this simply, if I can force you to practice it, if we can get you through this, what you, like, I say, hey, okay, this half of it's a weird half. I say, Peyton has to know this, Courtney does not. At the end of this course, who understands acidosis, ventilatory processes, who understands them better? Because she had to know what was happening. You say, well, why would I need to know this stuff? I can't ever test that. You can have a suspicion of it, and that's the point. How could you know that a patient has cardiac tamponade? How do you know? Ultrasound, right? Or what do they call it? Not an X-ray, but a CT scan, right? An echo maybe, these kind of things. So there's a lot of stuff we don't know, but we have to be clever enough to suspect it. And part of this comes back to a lot with refusals. The guy says, I feel fine. And I say, yeah, but antacids, it's probably throwing off your bicarb, or diarrhea isn't just dehydration, it's also metabolic shift.
So you may not be.
Yeah, you might not be fine tomorrow. I'm glad someone called today. A student suggested this slide to me, and so I'll show it to you now in the hopes that it may help you. But this is another way of framing If the pH is in the center, or specifically this should say 7.4, they are fully compensated. If the PaCO2 or HCO3 is in the center, they find that it's uncompensated. Why? Well, because it should be going to the other side to balance it. It's actually a problem. You can either have everything straight down the center, or nothing in the center, basically, to make sure that your body's working hard. Can you talk about this here, Ray? What's happening here? Tell me what you know about this. And if you can't see it, let me know, I'll read it out loud. What do you know about this patient, or suspect even?
That they're in metabolic alkalosis.
Amazing, yes. They are in metabolic acidosis. Why is the CO2, did I say it wrong?
Yeah. Said acidosis.
Jesus. They are in metabolic alkalosis. Why is their CO2 where it is? What's happening there?
They're not compensated.
They are not compensating. Where would it be if they were compensating?
It would be acidic.
Very good. You got it. It would be acidic. Now, let's take this patient here and say, oh, okay, well, I am somehow going to cause a hypoventilatory situation now to balance them out, and it's working. What else, if we move this here and it starts to work, what should we suspect changes?
Their pH is going to start to rise.
And what would be the difference between being able to determine whether or not it was partially compensated or fully compensated?
What are you asking? Say that again.
Sure. We've now shifted the CO2 to the left, which is going to balance out our HCO3 in the opposite direction. And as the pH shifts towards the normal, what would help me determine whether or not this patient is partially compensating or has fully compensated? How would I know the difference?
If it gets back to 7.4.
So let's say you shift the CO2 over, he starts retaining CO2, so it balances him out. We notice the pH shift into the normal range. But your patient's pH is not 7.4, it's 7.38. Give me his full name. He's in metabolic what with what? Your patient's pH is now 7.39.
Partially compensated respiratory acidosis.
That's correct. Sick, dude. Cool. I hope you feel good because having this discussion, I don't often get to have this discussion at the end of the lecture. The response is often, I don't know. The fact that you can hang in this arena of ideas is a very good sign. What you should not suspect is that when you go to practice it at home, that you remember anything I said.
That's the fun part.
That's what happens over and over. You're like, okay, I think I got it. You sit down, okay, so wait, what?
Yeah.
Right? And so you need to backtrack, you need to look at these charts, you need to look at these numbers. But again, the number one way through this stuff is to practice it. You say, okay, I have a patient with metabolic acidosis. What would that have to look like on this chart? What would their numbers have to be? I text Tina, hey Tina, shoot me a random, CO2, shoot me a random blood gas set of numbers. And it can be random, it can be it doesn't have to make sense for you to still try to figure out what the heck it is. Let me ask you this. A patient, you walk up to a patient with agonal respirations, what does their chart look like? They've been there for a day. Where's their pH? Okay. Where is their CO2? Where is their HCO3? Where?
Well, if they've been sitting for a day,
Yeah.
well, they would be acidic too, right?
Right? Which is why since the beginning we have said corpses are in respiratory and metabolic acidosis. So if you had a patient that fell and all of their three things fell in this category, that's a corpse probably. Because not only is it not compensating, it has fallen into decompensation as well. I don't know what would happen if all three were over here. I don't know what that looks like. That'd be a fun Google. What happens if you're in metabolic and respiratory alkalosis? Okay, gang.
You did anyways, cause you can't maintain the list.
Yeah, I mean,
Right, probably.
bad things, but like, specifically. Would be intriguing.
C did diarrhea to death.
Right? Okay, so we're gonna move into lab here. Let me pull this, well, in an hour.